Hello, algebra students. Mr. Lawrence here, and excuse me, going to go through some samples here from the review sheet. So let's just get down to this so it doesn't take too long. You can see here I've got problems 3 and 4. I'm going to rewrite problem 3 so I have a little room to show my work. So I've got 3y over 2 minus y equals 4 plus y over 2. Now when you have a problem of this complexity, okay, it's really not that bad. We know we need to multiply by 2 to get rid of these fractions, right? Well, I just have to remember to multiply everything by 2. So I'm going to multiply by 2 here, and I'm going to multiply by 2 here, and here, and here. I'm actually distributing on both sides of the equation. Okay, don't let this phase you. It's not that difficult. Here the 2's will cancel, leaving me with a 3y. Then I'll have 2 times y, minus 2y. 2 times 4 is 8. And here the 2's will cancel, leaving me with a plain old y. All right, so now I'm going to combine like terms. See these like terms here? 3y minus 2y is y equals 8 plus y. Some of you already know what the answer is. I'm going to subtract y from both sides. I should write that like that to be consistent. Y minus y is not y, it is 0. 0 equals 8. This is never true. This problem must have no solution. No solution for that problem there. Yeah. Okay, but it's not that difficult. All right, problem 4. Problem 4. I've got 5x over 8 plus 3/5 equals x. Okay, hold on a second here. All right, no, this is okay. I was thinking something wasn't right, but I'm okay. I need a number to multiply by that will get rid of both the 8 and the 5. Well, I need that least common multiple. Remember the least common multiple? I need 40. So I'm going to multiply by 40 here. I'm going to multiply by 40 here. And I'm going to multiply by 40 over here. Okay, so this will cancel with that. Please make sure you're showing your work. Too many of you are just like doing this in your head and getting it wrong. Show the canceling out, please. 5 times 5x is 25x. 5 is going to go into 48 times. 8 times 3 is 24. And 40 times x is 40x. I've got x's on both sides of my equation. I don't like that, so I'm going to take one of them away. I like to usually take away the smaller coefficient of x, and you've heard me say that before. So those will cancel. I'll be left with 24 equals 15x. I'll divide by 15. Again, don't skip steps. Show that step. All right, so x is going to be the same as, you know what, I'm not going to skip sides there because some of you are imitating that incorrectly on inequalities. So I'm going to keep them on the same side. I'm going to get x on the right-hand side and this side 24/15. So I'm going to simplify first of all. I think they can both be divided by 3 and get 8/5, not 8/3, excuse me. 8/5, that is. And then to go mixed number, I'm going to get 1 3/5. And that's what x is. All right, let's see what the next set of problems look like. Problem 10, I've got 12 minus x over 6 is greater than x plus 7 over 4. Well, I've got fractions. I don't like the denominator, so I'm going to multiply by a number, the smallest number I can, at least common multiple, that will get rid of both 6 and 4. It's not 24 in this case, it's actually 12. So I'm going to multiply by 12 here, multiply by 12 here, and again, when I do this, show the work. 6 goes into 12 2 times. Ooh, look, there is something left to distribute. There is something left to distribute. That'll be 24 minus 2x. That'll be greater than, 4 goes in 12 3 times. 3 times x is 3x. 3 times 7 is 21. I don't like having x's on both sides. I'm going to get rid of this negative 2x from both sides. I'll get 24. Those will cancel. Greater than 5x plus 21. Then I will subtract 21 from both sides. And I'll end up with 3 is greater than 5x. Divide by 5. Will my inequality flip, Sam? What do you think? Am I going to flip the inequality? 3/5 is going to be greater than x. No, it won't flip because I didn't multiply or divide by a negative. There is my solution. Now, if we need a solution set, of course, x is going to be any real number such that x is less than 3/5. Some of you will be, well, like you changed it. Well, no, I didn't. 3/5 is greater than x. Means the same thing as x is less than 3/5, doesn't it? Here, 3/5 greater than x. Fill in a value for x. 3/5 is greater than 0. Sure it is. Okay, well, let's try mine. Blank is less than 3/5. 0 is less than 3/5. You see, I'm going to get the same numbers. If you pick a number that makes yours false, like say, here, let's get rid of this 0. And let's stick a number that makes it false in there, like 10. Is 3/5 greater than 10? Definitely not. Well, let's try it on mine. Let's stick 10 in its place. Is 10 less than 3/5? Definitely not. All right, so there you go. Of course, on a number line, graphing that on a number line, I'd have to show 3/5. I'd probably show 0, probably show 1. It's going to be an open point because it's not equal to. I need numbers less than 3/5, and that would be the numbers to the left of 3/5. And so it looks something like that. All right, number 11. I've got 2x over 5 minus 4x over 6 is less than 4. If you're really sharp and you want to simplify this fraction before you multiply, you certainly can do that. Tell you what, I'm going to pretend like I didn't notice that, and I'm going to find my least common multiple of 5 and 6. Hopefully you recognize that as 30. So I'm going to multiply each fraction or each term by 30. And so I'll get 120. Here the 6 will go into 35 times. 5 times 4x is negative 20x. 5 goes into 36 times. 6 times 2x is 12x. So I'll combine the like terms here because they're on the same side of the inequality, so I don't subtract or anything. I'll get negative 8x is less than 120. And if I divide by negative 8, yeah, Sam, this is where it's going to flip. We're going to get x is greater than negative 15. Yeah, my solution set would be x is any real number such that x is greater than negative 15. And of course, the number line graph would look something like this. I got a negative 15, a negative 14, a negative 16, and there will be an open point at negative 15. I want the numbers greater than negative 15. They would be to the right. If you need to, test it. Test it. Pick an obvious number like 10. Wouldn't 10 be over here somewhere? Right, probably off the page. All right, moving right along. Let's try some compound inequalities here. Now, these are real easy. I'm just going to solve the two pieces, but I'm going to graph them on the same number line. So I'm going to get 2x is greater than 16. I'm going to divide by 2, and x is going to be greater than 8. And then I'm going to add 6 here. I'm going to get 2x is less than 10. I'll divide by 2. And so x is going to be less than 5. So I have x is greater than 8 or x is less than 5. If you wanted to do a solution set, it might look something like this. X is less than 5 or x is greater than 8. And my number line would have to have a 5 on it, have to have an 8 on it. Since they're not equal to, they'll both be open points. Now, where are the numbers less than 5? Well, they're to the left of 5. And where are the numbers greater than 8? Well, they're to the right of 8 on the number line. And there you go. Okay, number 13. I'm going to subtract 6. Get negative 3x is less than or equal to 6. Divide by negative 3. You should have some warning lights going off. X is going to be greater than or equal to negative 2. Notice the inequality flip because I divided by a negative on both sides. And I have to come over here and do this side. Subtract 6. Negative 3x is going to be greater than or equal to negative 6. 0 minus 6 is negative 6. Divide by negative 3, and there go those warning lights again. X, well, I guess I should write down here, x is going to be less than or equal to positive 2. So let me get this little marker out of the way. So now I'm ready to write the solution set. And I'm going to get x as any real number such that negative 2 is less than or equal to x, which is less than or equal to 2. You could write it with an and, but I wanted to model how to do it without the word and. By the way, you can never write an or without the word or. And is the only one that can be written this way. All right, so my number line will have to show negative 2 and positive 2. I can show other numbers if I like. Close points because they're equal to. And if I want to fill in the blank with a number that makes both of these true at the same time, maybe I'll pick 0. And 0 would be in the middle here, so I'm going to shade in between. Remember, ORs tend to look like this. There's only the one exception, which I've only mentioned. I haven't really gone over. We're not going to see that exception on the test. And ands look like this one here, okay? Again, there is an exception, but we're not going to get to that now. Just planting a seed for later. All right, 2 more problems. The difference, that's subtract. What am I going to subtract? Of 7 and twice a number. Now, some of you are thinking, hey, it's 2n minus 7. And I disagree. Because if I said the difference of 5 and 3, wouldn't you do 5 minus 3? If I said the difference of 10 and 7, wouldn't you do that? Notice the number that comes first in the expression. So when I say the difference of 7 and twice a number, the 7 is going to come first in this case. So you see it's going to be 7 minus twice a number. Well, that will be 2n, is 31. And now I'm getting ready to solve my inequality. So I'm going to subtract 7. I'll get negative 2n is equal to 24. I'll divide by negative 2, divide by negative 2. There's no inequality, so I don't have to worry about flipping anything. So n is going to be equal to negative 12. All right, negative 12. Yeah, that's the number. I can test it. Let's do 7 minus 2 times negative 12. Let's see, I'm going to get 7 minus 2 times negative 12, negative 24. Minus a negative is the same as plus a positive, right? Taking away a negative is the same as adding a positive. 7 plus 24, 31. And look at that, it's supposed to equal 31. So tried to trick you there. I didn't do the difference of twice a number and 7. I didn't do 7 less than twice a number. I did the difference of 7 and twice a number. This one comes first. Why? Because it comes first in the sentence. All right, 17. The quotient, going to need a division bar, quotient of the quantity. Quantity is going to be my numerator. What's in the quantity? The quantity of 10 less than a number tripled and 4. There we go. Uh-oh. This problem... Nope, I'm okay. I just did it in the wrong spot. Sorry, let me get that quantity. Sorry about that. Confused myself for a second. 10 less than a number tripled. Okay, there's the quantity. And 4. This is the denominator of the quotient. How do you know that? Because it comes after the and. Okay, so there's going to be a 4 down here. 10 less than a number tripled. Well, a number is n. A number tripled is 3n. 10 less is minus 10. So 3n minus 10 is greater than twice the number. Well, what's the number? N, and greater than twice the number is 2n. So there you go. There's your inequality. Now, I don't like this fraction. I'm going to multiply to get rid of it. Multiply on both sides. Very important. Some of you are forgetting to multiply on both sides. The 4's cancel. There's nothing left to distribute. I have 3n minus 10 is greater than 2 times 4 is 8, 8n. I don't like having variables on both sides. I'll get rid of the one with the smaller coefficient. I'll get negative 10 is greater than 5n. I'm going to divide by 5 on both sides. Will the inequality flip on this one, Maggie? No, that's right, Maggie. The inequality will not flip because I did not divide by a negative. Read this. 5n divided by 5. Did I say a negative? No, I didn't say divided by a negative number. How about this one? Negative 10 divided by 5. Did I say divided by a negative? Absolutely not. So you see the inequality does not flip. Okay, solution set would be n is any real number such that n is less than negative 2. On a number line, that would look like this. Negative 2, negative 3. Make sure you're numbering your number lines correctly. Okay, at this point in algebra, you can't be numbering them backwards. All right, it's an open point because it's not equal to. Any numbers less than negative 2. Well, how about negative 3? It's all shade towards negative 3. So any number less than negative 2 makes this inequality true. One last thing I want to talk about, I hope Mr. Cooper's paying attention to this. If I have 5 minus x over 2 is greater than, say, 7. Now, Mr. Lawrence likes to subtract 5, but I got a feeling, Alex, you like to multiply first. You want to say, hey, Mr. Lawrence, I'm going to multiply this by 2. And I'm going to multiply this by 2. And I'm okay with that, Alex, except you have to remember to multiply the 5 by 2. You cannot multiply part of a side by 2. You have to multiply the entire side of the inequality. You actually have to multiply both sides. Don't forget that. There's a lot of people who forget to multiply both sides. They do this side fine, and they forget about the 2 over there. But if you're going to multiply first to get rid of the fraction, you have to multiply all the terms by 2. So 2 times 5 is 10, minus the 2's cancel, so I get x. That's greater than 14. I'll subtract 10 from both sides. I'll get negative x is greater than 4, but I don't care about negative x. So I'm going to divide both sides by negative 1. X will be less than negative 4. Watch this. What's 4 divided by negative 1? Did you notice I said divided by negative 1? When you say divided by a negative on both sides of the inequality, then the less than becomes greater than, or the greater than becomes less than. Okay? One more thing you need to watch out for, ladies and gentlemen. If you have 4x minus 5 is equal to 7 minus 4x, and you say, hey, I'm going to add 4x to both sides. Please pay attention here. Those cancel. Those do not. You end up with 8x minus 5 equals 7. I'll add 5 to both sides. Oops, I don't want to divide there, excuse me. Okay, I'm going to add 5 to both sides. And 8x is going to equal 12. I'll divide by 8. Divide by 8. X is going to equal 3/2 or 1.5. Okay. Watch for things like 5x minus 5x. That does not equal x. It equals 0. And if you're solving an equation and you get a 0, you have to have the 0 on that side if there's no other numbers. All right, that's it for the video. We're going to review in class tomorrow. Hey, by the way, I love the football game. I was very impressed with the quarterback's arm and some of the speed on the passes and the running plays. You guys really stuck it to Normandy, or Hillside, that is. Anyway, Mr. Lawrence signing off. Have a good night, everybody.